Good morning. An object is in equilibrium if the net force acting on that object is equal to 0.
Flippin' physics.
Billy, if the net force acting on an object is equal to 0, what is happening to the object?
An object in equilibrium has 0 net force acting on it, so it isn't moving, right?
An object that is not moving is in equilibrium. However, an object in equilibrium is not necessarily at rest. In other words, if an object isn't moving, it is in equilibrium. However, an object that is moving can also be in equilibrium. Bobby, please use Newton's second law to explain this concept.
Well, Newton's second law tells us that the net force acting on an object equals the mass of that object times its acceleration.
Where both acceleration and force are vectors.
Right. And if the net force equals 0, then the acceleration of the object is 0.
And acceleration equals change in velocity over change in time, so the change in velocity of the object is 0.
Yeah, so if an object is in equilibrium and moving, it will maintain a constant velocity.
Correct. When an object is in equilibrium, the net force acting on that object is equal to 0, and according to Newton's second law, the net force is always equal to mass times acceleration. Therefore, the acceleration of the object is equal to 0, and acceleration equals change in velocity over change in time. Therefore, the change in velocity of the object is equal to 0. Therefore, the velocity of the object is not changing. Which means an object in equilibrium is either at rest or moving with a constant velocity.
Isn't an object at rest maintaining a constant velocity of 0?
Yes.
Yeah.
Sometimes people refer to equilibrium or all the forces adding up to 0 as the forces balancing out. In other words, all the rightward forces balance out with the leftward forces, and the upward forces balance out with the downward forces. So equilibrium, all the forces balancing out. Let's talk about some examples. This book on an incline is an object at rest. Bobby, what are the forces currently acting on the book?
The force of gravity is straight down. The normal force from the table is pushing up and perpendicular to the table. And a force of friction is parallel to and up the incline.
Correct. And when we add all those forces together, they add up to 0. Which is why the book is still at rest, because the book is in equilibrium. Now, let's look at a vehicle moving at a constant velocity. The forces acting on the car are the force normal up, the force of gravity down, the force applied forward, and the force of friction backward. It is an object in equilibrium, so all those forces add up to 0. The net force in the y direction equals 0, the net force in the x direction equals 0, and therefore the net force in all directions equals 0. Therefore, the car continues to move at a constant velocity. This type of equilibrium is called translational equilibrium, which means non-rotational equilibrium. Translational equilibrium, where the net force acting on an object is equal to 0, therefore the object is either at rest or moving at a constant velocity. Thank you very much for learning with me today. I enjoyed learning with you.